Okay, Chapter 8 practice test. This is it. This is our last test, and it's on systems, and this is going to be the Chapter 8 review. Okay, so let's do a few of these questions. This one starts off with a few multiple choice. It says the sum of two integers is -5. 10 times the larger is subtracted from the square of the... Oh, okay, it's complicated. Take a look at the answers. We've got x and y. So obviously the sum of two integers is -5. So if x is one of the integer and y is the other one, I know that x plus y is equal to -5, right? So in other words, x plus y is equal to x plus y is equal to -5. That one could work. That one's definitely wrong, right? I know that's wrong. X plus 5, hang on, if I was to bring over the 5, x plus 5 plus y is equal to 0, that would be minus y. X plus 5 is equal to y. This one's definitely wrong. Okay, so x plus 5 is equal to minus y. That could work. So both of these, A and C, so far look okay. Let's see, what's the other one? It says when 10 times the larger one is subtracted from the square. Well, which one's larger, x or y? I don't know. But look, they say 10 times y, 10 times x. Well, let's start it off with y. If, let's say 10 times the larger one, so that's 10y, is subtracted off from the square of the smaller one, is subtracted off of x squared, the result is 34, equals 34. Okay, is that my equation? X squared minus 10y, that seems to work. What about this one? X squared minus 34 is equal to, see, if I brought over the x squared minus 34, if I brought that over there, it becomes positive 10y. That's why this one's wrong. Okay, so the first one's got to be A. Yikes. Okay, so that was an awful lot, but quite often you can throw away some of the answers right off the bat. Okay, given the graphs of a linear function and a quadratic, what is the solution set? Remember, this is the intersections. So I'm looking for intersection points. Now notice they put a whole bunch of dots on these graphs. They put this one and this one just to basically show you this is parabolic in nature, but I'm only looking for the intersection. So there's one. So this is -1, 0. Yes, yes, no, no. Could be B or C. And the other intersection, careful, it's not here. It's here. It's the intersection of the line and the parabola. So this is 3 and minus 4. 3 and minus 4. It's this one. Okay, so 2's got to be B. Okay, a rectangular field is enclosed by 600 meters of fencing. So we've got a rectangle. Let's do this. Let's see if I can draw a rectangle or a reasonable facsimile. I know it's 600 all the way around, right? Which means the half parameter from here to here is 300. So you know what? I'm going to call this x. I'm going to call this 300 minus x because that way, remember, when you add these two together, you get 300. Yeah, so if this was like 10, this would be 290, right? 300 minus 10. So think about it. If I add these two together, the x's cancel out, I get 300. So this is 300, which means that this is 300. Okay. It says a second rectangular field, which is alongside a river, has the same area. So the area here, the area is really x times 300 minus x. You know what? Expand that all out. I'm going to get an equation here. A is equal to 300x minus x squared. Or in other words, minus x squared, that's plus x squared. That one's definitely wrong. Area is minus x squared plus 300x minus, oh, that one could work. That one could work. Minus 2x, oh yeah, it's definitely no. It's not that one. So it's either got to be B or C. Okay, now what? A second rectangular field, which is alongside a river. Okay, so here's my river. And I've got a rectangle here, which means it only has 3 sides. Okay, it's also enclosed by 600 meters. Okay, so if I call this, I don't know, I'll make, I don't know if this is the same x or a different x. They're using x's again. But if I use this as x and x, it might be a different x, who knows. I know that this is going to be 600 minus 2 x's. Okay, yeah, because if I go 600 minus this, I'll get that. So the area of this one is really x times 600 minus 2x. Okay, so hang on. This is 600x minus 2x squared. Oh, maybe I shouldn't have been so quick to throw away the 2x squared. Oh, but hang on, there's a 2x squared there. Hang on, so what do we got? Area is equal to 600x minus 2x squared. Area is 600x minus 2x squared. There it is, it's B. This is x plus y is 300? No. I don't know that those add up to, and besides, I don't know what y is, but This is a weird question. Um, there's more than one way of setting this one up. I initially set this up as x, and then this is something else, and it's not going to work. This is a kind of complicated question, probably way harder than you would see on a multiple choice. Besides, the problem with this one, it's not that it's a system, it's just it's a convoluted question. Yeah, poor question. Not going to see it on a test. Okay, let's see. Number 4, what is the solution to the following linear quadratic system? Okay, so there's a few different ways we could do this. We could graph this. You could also just plug in these numbers, right? Some of them are going to work. What do you mean? Let's say I take 3 and 2. The x value is 2, the y value is 3. 3 is equal to 6 minus 3. Yeah, that works. But does it work in the other one? 3 is equal to negative 4 plus 8 minus 1. You know what? Maybe I should either graph these or I could do this by algebraic means. You know what? This one's not that bad. It's in fact beautiful to do it algebraically because look, you've already solved for y. Y is equal to this. I can take that and plug it right into there. Yeah, if y is equal to 3x minus 3, that means I can put it, okay, so let's do this. So 3x minus 3 is equal to negative x squared plus 4x minus 1. So let's bring that positive x squared over. X squared minus off 4x minus off 4x minus 1x plus 1 plus 1 minus 2 is equal to 0. You know what? This is a pretty easy one to solve now. X minus 2, x plus 1. So x is either equal to positive 2 or x is equal to negative 1. Oh, there it is. X is negative 1, positive 2. Oh, yeah. So I know I'm going to get two solutions. That's why B and C are wrong. Okay, so what is the y value, though? Well, look, go back to the easiest equation. This was the easier one, right? Y is equal to 3 times x minus 3. Thank you. Alrighty, so let's plug this in. 2 times, so it's going to be 6 minus 3. The y value is 3. So 2 comma 3. Now that one? Oh, it's got to be D. You know what? If I plug in the last one, x is equal to negative 1. If I was to plug in, I'd get negative 3 minus 3, which is negative 6. There it is. Okay, so 4D done. Number 5, how many real solutions exist for this quadratic system? Well, I'm not exactly sure, but I do know that y is equal to this and y is equal to that. So therefore, I could say this is equal to that, right? Basically, I'm taking this entire thing and I'm substituting it into the y right there. Okay, let's try and solve this thing. So in other words, what do I get? I get x squared minus 3x plus 1 is equal to this thing. Negative 2x squared plus 2x minus 7. So add on the 2x squared, I'm going to get 3x squared. Minus off 2x, I would get minus 5x. Add on 7, I get plus 8 is equal to 0. Okay, so two numbers that multiply to 24 and add up to, hang on, they multiply to 24. So they're either both positive or they're both negative. And they add up to negative 5. I don't know if I can factor this thing. Why don't I just go, this is a quadratic, right? Why don't I simply do this? Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, let's do that. Negative b, which is positive 5, plus or minus the square root of b squared, so negative 5 squared, 25, minus 4 times 3 times 8. Whoa, hang on. All over 2 times 3, which is 6. Look what I get. I'm getting 4 times 3, which is 12. 12 times 8 is 96. I'm going to get 25 minus 96. That's negative. Negative inside of a square root means there is no answers. How many real solutions? There are no answers because it's impossible. In other words, these are two parabolas that miss. Well, think about it. This is a parabola that's facing up, and this is a parabola that's facing down. They probably miss each other, and that's exactly what happens here. Now, I didn't know that unless I actually graphed this on my calculator. I could have done that, but this is pretty quick to do to figure out the number of solutions. Okay. Determine this solution algebraically. Look, y is equal to this, y is equal to that. I could add and subtract and stuff like that, but it's way easier to do this by substitution. Okay, so in other words, this thing is equal to y, plug it in right there. So in other words, negative x plus 3 is equal to negative x squared minus 6x plus 3. You know what? Add on x squared to both sides, plus x squared. It's gone. Add on 6x to both sides, plus 5x. Minus 3 minus 3. Whoa, Okay, so the 3's canceled. So here's my equation. This is all I'm left with. X squared plus 5x is equal to 0. How do I solve that quadratic? I could go to a quadratic formula. Hang on, this thing is really fast to factor. Oh yeah, right? Factor out the x. Whew. So either x is equal to 0, and 0 is a number, that's an answer, or x is equal to -5. Okay, now what? If x is equal to 0, tell me what y is. Look, y is equal to -x plus 3. Oh yeah, that's the fast way of doing it. Plug it into the easier equation. Y is equal to -0 plus 3. In other words, y is equal to 3. So here's my point, 0, 3. And here's the other one. So -x, negative of -5, that means 5, plus 3. So the y value is going to be 5 and 3 is 8. So -5 and 8. So there's my two solution points. Because it's a line and a parabola, which means, yep, they actually intersect at two spots. Okay, it says, give an example of a quadratic that would produce an infinite number of solutions in a quadratic system where one of the equations is this. Okay, so this is one of the equations. The first equation is y is equal to x squared plus 6x minus 5. Okay, so it says it has an infinite number of solutions. So in other words, that's one parabola. And the other parabola, because it has an infinite number of solutions, the other parabola is like right on top of it, and it's the exact same parabola. Oh, that's terrible. So it's not really a system, is it? The other parabola, because it's got an infinite number of points where they all intersect. So in other words, here's the other equation. It's going to be the exact same thing, but like doubled. 2y is equal to 2x squared plus 12x minus 10. Okay? Now that's the exact same equation because it's the exact same parabola. Now, I just doubled everything because that was an easy thing to do. You don't have to double it. I could have said that negative y is equal to negative x squared minus 6x plus 5. See, I just multiplied everything by -1. I really get the exact same equation, and that's what I want. I want two of the exact same equation, even though they might look different. Or you know what? You could have factored this thing, right? Oh, actually, I don't think it will factor, right? 5 and 1 minus 5 plus 1. No, it won't factor. But I also could have said 10y is equal to 10x squared plus 60x minus 50, right? There's an infinite number of different ways of rewriting it. All I care is that it's the same parabola. Same parabola. Why do I know it's the same? Because it says there's an infinite number of solutions. One is right on top of the other one. Okay, number 8. It says verify that this is the solution. Well, let's plug it in. Let's take this one and we're going to plug in the x value and the y value. So in other words, 2 times 3 squared plus 3 minus 7, is that equal to 14? Well, I don't know. Let's figure it out. 9, so this is 18 plus 3 minus 7. 21 minus 7, which is 14. Yes, it is. Okay, now hang on. Does it work in the other one as well? I should have gone with this one because this one is the easier equation. Okay. 3x, x is 3, plus y is 14, minus 23 is equal to 0. 9 plus 14 minus 23. This is 23. Hang on. This works. Yes, it does. So yes. Is it the solution? Yes, because it works in both equations. It works in this one and it works in that one. It's got to work in both. Now, if it didn't work in this first one, I wouldn't even bother care about this one because I know that it's just the answer is no. Now it says, are there any other solutions? Hang on, this is a line, degree 1, and this is a parabola, degree 2, right? A parabola and a line could hit at 2 points. Okay, well, let's see. Are there any other solutions? How do I solve this one? Maybe look, I've already got y is equal to, right? They've already isolated y. Let's do the same thing here, right? 3x plus y. So 3x plus y minus 23 is equal to 0. Let's just isolate y. So minus off 3x from both sides. Minus 3x minus 3x. Plus 23 plus 23 plus 23. So this is what y is equal to. Negative 3x plus 23. And if I take that and I plug it into the other equation, not here, plug it into there, right? There's the other equation. The other equation is a parabola. Let's take this and plug it into there. Let's actually solve this thing. Okay, so here we go. 2x squared plus x minus 7 is equal to y. There's my y. Minus 3x plus 23. This is a quadratic. Add on 3x to both sides. I'm going to get plus 4x. Minus off 23, minus off 23. I'm going to get minus 30. Okay, so 2x squared plus 4x minus 30. I can divide everything by 2. Now, I'm not going to factor out 2. I don't need to do that. No, because here's a faster thing to do. Just divide everything by 2. Divide by 2, divide by 2. Why? Because 0 divided by 2 is still 0. This becomes x squared plus 7x minus 15. 5 times 3, is that what this thing... hang on. Two numbers that multiply to give me 15. Hang on, that's not 14, that's 4. What am I doing here? Silly, silly, silly. This should be 2. Oh, there we go. Yeah. Now it makes sense, right? Two numbers multiplied to 15, x plus 5, x minus 3. So here's my two answers. X is equal to negative 5, or x is equal to positive 3. This was already the positive 3 solution. So we've already used this one up. Here's the other solution. The other solution is going to be negative 5, and what's the y value? Negative 15 minus or plus 23. Oh no, it's positive 15. It's going to be 38. So the other one is going to be negative 5 comma 38. That's the other solution. Now it just says, are there any other solutions? Yes. Here it is. There it is. Okay. Determine algebraically the solution set to this quadratic. Okay, so once again, y is equal to. Now, you might just say, hey, why don't I double this, right? And then these will cancel. You're right, but these ones won't. See? I can't do this by elimination because I don't get all the x's to cancel. Now, I could, of course, subtract y minus y, which is 0. That's a pretty easy way to do this. Watch, I'm going to subtract y minus y, 0. Negative 2x squared minus negative x squared. Minus 2x squared minus x squared. That makes it plus. This becomes negative 1x squared. Negative 3x minus. That makes it plus. So minus 2x. 3 minus 7 quarters. Now hang on. 3 is the same as saying 12 quarters, right? Minus off 7 quarters, I'm going to get 5 quarters. Hang on, is it positive or negative? Positive minuses, positive 5 quarters. Okay, so all I did was I really subtracted the 2 in order to cancel out the y's. This is the exact same as if I have simply substituted one into the other. Okay, so this is an ugly looking thing. I'm going to times everything by negative 1 right off the bat. Times negative 1 times negative 1. 0 is equal to 1x squared plus 2x minus 5 quarters. Okay, now what? You know what? I'm going to times everything by 4. Why? Because I don't like that quarter. So if I times everything by 4, I'm going to get 0 is equal to 4x squared plus 8x minus 5. Put the 0 over here. It's just easier to put over here. Because now I recognize this is a quadratic. And you know what? I can actually solve this thing. Because this is two numbers that multiply to give me negative 20. Multiply to equal negative 20. And they add up to 8. So in other words, one's positive, one's negative, because they multiply to a negative. 10 and 2, yeah, that'll work. Yeah, so positive 10, negative 2. Okay, so remember, this is decomposition. This one breaks into 10. I'm going to put the 10 beside the 5. So 10x, and then minus 2x. So this is plus 10, this is minus 2x. Okay, and then I still have the 4x squared out front. These two, I can factor something out of them, right? What can I factor out of these two? I can divide out of 2. I can also divide out an x. 2x, bracket, 2x plus 1. No, minus 1. Okay. What about these two? I should be able to factor something out. I can divide out 5. Bracket 2x minus 1. Hey, sweetness. See that? I've got the same factor. So 2x minus 1 is one of the factors, and 2x plus 5 is the other one. Now, if this is equal to 0, that means here's my two solutions. X is equal to positive 1/2, or x is equal to negative 5, and then divide by 2. Negative 5/2. So negative, hang on, 5 over 2, not 5 over 5. 5/2. So in other words, 2.5. So this is 0.5 and negative 2.5. So determine the solution set. So now that I have x, how do I figure out y? I have to plug it into one of these equations. Which one? Whichever one you think is easier. I'm going to go with the first one because it has no fractions. Let's do that. Negative 2x squared minus 3x plus, okay, let's do it. So y is equal to negative 2x squared minus 3x plus 3. And I'm plugging in 1/2. So negative 2, 1/2 squared, half times a half is a quarter. Minus 3 times a half plus 3. So what do I get? I get negative 2 quarters. Hang on, negative 2 quarters, isn't that the same as a half? Yes, it is. Minus 3/2 plus 3. So this is minus a half minus 3/2, which is minus 4/2, which is negative 2. So that's what this thing becomes. So this becomes negative 2 plus 3. In other words, 1. So here's my first solution. When the x value is a half, the y value is 1. Let's do the other one. Y is equal to negative 2x squared minus 3x plus 3. Do I have to plug it into the other equation? No, I can still use the same one because I'm just trying to figure out y. I'm just plugging in a different x value now. Okay, so negative 2 times 5 over 2 squared, so it's going to be 25 over 4. Squared is always positive, right? Minus 3 times minus 5 over 2 plus 3. So what do I get? I get negative 50 over 4. Negative 50 over 4. You know what? Make them halves. Make this 25 over 2. Because I can see this is going to be halves. So let's make this a 25 over 2 right now. Duh. I could have just canceled out the 2, right? Oh yeah, there we go. Minus minus is going to be plus 15 halves plus 3. So this becomes negative 10 halves. In other words, it's negative 5. Negative 5 plus 3, which is negative 2. So this whole thing should become negative 2. So here it is. When the x value, there's the y value. When the x value is negative 2.5, or negative 5 on 2, the y value is negative 2. So there's my other point. So there's the 2 points of intersection. So that one was a little bit uglier. Now, luckily, the fractions weren't that bad. And yes, I could have turned these into 0.5s if I really wanted to, because they turn out to be nice 0.5s. Whoa, this thing got stretched. Determine the value of k. So I want to figure out what is k. I don't know. What is m? So they say this is a solution. So in other words, if I plug in the x and y value, it should actually work. Okay, so what? This one's got k and m. This one just has m. Let's start over here. So the x value is negative 3. Negative 3 squared is 9. 6 times negative 3, so this is negative 18. Plus y. Y is 4. Plus m is equal to 0. There's only one letter here. I can actually figure out what m is. Cool, let's do that. Okay, so this is 9 minus 18, which is minus 9, plus 4, which is minus 5. Let's bring the 5 over to the other side, add on 5, and I'm left with my m. See? So really this became minus 5 plus m is equal to 0, and then I just moved that over. M is equal to positive 5. So now that I know that m is equal to positive 5, I can plug that in right here. So x squared, x is negative 3, x squared, maybe I should actually do it in brackets. Let's do it. X squared plus k times x, and x is minus 3, right? Minus 2 times y, y is 4, plus m, I just figured out m is 5, is equal to 0. I have an equation just in k's. Cool, let's do this. 9 minus 3k minus 8 plus 5 is equal to 0. 9 minus 8 is 1. 1 plus 5 is 6. So minus 3k plus 6 is equal to 0. Bring the 6 over. Minus 6 is equal to minus 3k. K has got to equal 2. K must equal 2. So the m value is 5. The k value is 2. Okay. What about this one? This is a different system, right? Y is equal to, this one's got k's and m's. Y is equal to, this has just got m's and x's. Let's start here once again, right? So I have to figure out what is k and m. I have a feeling it's a different k and a different m because it's a different system. However, this is still my x and y. So y is equal to m times x plus 10. Okay, so what am I going to do? I'm going to go minus 10 minus 10. So I'm going to get minus 6 is equal to negative 3 times m. Divide by negative 3, divide by negative 3. M must be equal to 2. So it's a different value. So here it was 5. Now m is 2. However, now I can plug that in. Let's do it. Y, so in other words, 4, is equal to negative 2 times negative 3 squared minus k times negative 3 minus m. And m is 2. So 9 times negative 2 minus 18, 4 is equal to minus 18 plus 3k minus 2. So this is 16 plus 3k is equal to 4 minus 16 from both sides. I'm going to get minus 12 is equal to 3k. So now divide by 3, divide by 3. K must equal negative 4. Hang on, did I do that right? Negative 18. Oh, this is minus. I think I've done this. Oh, I dropped a minus. It's going to make a difference. Let's see. This is 9 times negative 2, which is negative 18. Oh, okay. Hang on. Let's see how that changes. Negative 18 and negative 2. This is not 16. This is negative 20. So then when I add on 20 to both sides, this becomes, plus 20. This becomes not negative 12. This becomes positive 24. Now, luckily, it's still divisible by 3. Whew. Okay, there we go. So now k is equal to 8. Okay. Let's see. What do we got last here? This point is a solution to the following system. Okay. So we know we can plug it in. They're telling us it's a solution. So how many solutions are there for k? I have to figure out what k is. So they're telling me that this is a solution. So if I plug it in here, it should work. Let's figure out what k is. Okay, so y, x, right? So y is equal to 2 times 2. 2 minus k squared minus 3. So in other words, let's actually try and solve this. Add on 3 to both sides. 8. 2. 2 minus k squared. Divide by 2, divide by 2. 4. 4 is equal to 2 minus k squared. So in other words, what number squared is 4? Well, this has got to be 2, but this could be plus 2 or minus 2. So in other words, 2 minus k could equal positive 2, or 2 minus k could equal negative 2, right? So hang on. If I subtract off 2, I get minus k is equal to 0, or subtract off 2, subtract 2. I get minus k is equal to minus 4. So either k is equal to 0, or k is equal to 4. I get two different solutions. Determine the values k. I just did. So how did we figure that out? I said, well, this is a parabola, and they tell me it's a solution. Okay, so I know it's got to work here. However, I don't know what k is. It says, how many solutions are there? So I plugged in my x and y into here to try and figure out, let's figure out what k is, and I end up getting a quadratic. And I know a quadratic could have two solutions. Right? And this quadratic does have, now I could have expanded it all out. However, I recognize this. Oh yeah, I know the square root of 4 is 2. So it's plus or minus 2, right? Plus 2 or minus 2. It's one or the other. Okay, so for one of these values, determine the other solution. we could do either one. I'm going to go for the easier one. Let's say k is equal to 0, right? So if k is equal to 0, that means that this has got to be 0. That means that y is equal to 2x squared minus 3 is one of my equations. So I'm going to pick if k is equal to 0, expressed to the nearest hundredth. Let's see. Therefore, I know here are my two equations. Y is equal to 2x squared minus 3. Y is equal to 2x squared minus 3. And what's the other one? It's this one. Y is equal to negative a third x minus 2 squared. Okay, that's a beast. Y is equal to negative a third x minus 2 squared plus 5. So in other words, here's one parabola, here's the other one. Let's actually put these together somehow and solve this system. Now, remember, I've already isolated y is equal to. So I could take that and I could plug it right into there. That's probably the easiest thing to do, right? Because that's a substitution. So let's do that. Let's take this and plug it right into here. So in other words, 2x squared minus 3 is equal to negative a third, bracket, x minus 2 squared plus 5. Yikes. This is a big equation. Let's add on 5 to both sides. Add on 5? Sure. I'm just going to go plus 5, plus 5. That way it gets rid of this one. Or sorry, minus 5. Minus 5, minus 5. Because I know it'll combine there. So here's what I get. 2x squared minus 8 is equal to negative a third x minus 2 squared. Okay? That makes it a little bit smaller. I'm going to multiply everything by 3 right now. Why? In fact, maybe I'll multiply by negative 3 just so it gets rid of this, right? Because then this becomes, so let's multiply everything on both sides, negative 3, negative 3. So this side times by that, and that's, so this becomes x minus 2 squared. That's way easier. Now this becomes negative 6x squared plus 24. But you know what? I got rid of the fraction. And this is not that hard to expand out. X squared minus 4x plus 4 minus 6x squared plus 24. I'm getting closer. X squared, let's put them both together. So plus 6x to both, sorry, plus 6x squared. This becomes a 7x squared minus 4x minus 24 minus 24. Okay, so this is getting smaller and smaller. Hang on, can I actually factor this thing? Two numbers that multiply to give me negative 140, and they add up to negative, hang on, multiply equal to negative 140, and they add up to negative 4, that'd be 14 and 10, wouldn't it? Hang on, minus 4. Minus 14? Yeah, that'll work, because I want two numbers that multiply to negative 140, and they add up to negative 4. There it is. This one actually factors pretty easily. Now, let's do this. 0 is equal to 7x squared. I'll put the 14 beside here. Minus 14x. And then the plus 10, plus 10x, minus 20. So here I can factor out 7x, bracket, x minus 2. Here I can factor out plus 10, bracket, x minus 2. So here we go. We're in our last step. So it's x minus 2, bracket, 7x plus 10. So here's my two answers. Either x is equal to 2 or x is equal to negative 10 sevenths. Yikes, that's not a very nice number. This is going to be like negative 1.43, I think, or something like that. Whatever it is. The other answer, this is a way nicer answer. Now, hang on. That's just the x value. I want to know the solutions as an x and y point. So how do I figure out the y value? Well, I could plug it either into this equation or this one. Let's go for the easier one. 2x squared minus 3. So y is equal to 2x squared minus 3. So this is 8 minus 3, which is 5. So here's my first point. Whoa, let's clean that up. The x value is 2. The y value is 5. Okay, and this one, it said goes to the nearest hundredth, so that's 2 decimal places. Okay, so hang on. Negative 10 over 7 is negative 1 and 3/7. 1, 4, 2, 8, 5, 7. I don't know if you've ever seen the rule of sevenths. This is 1/7 repeating, right? Because it goes 1, 4, 2, 8. 2/7 starts at the 2. It goes 2, 8, 5, 7, 1, 4, repeating. What? Yeah. 2/7 is going to be 0.285714 repeating. Okay, what comes after 2? There is no 3, so it starts at 4. Hang on, let's put our 1, 4 back in front here. Remember we had it here? 1, 4. So in other words, start at the 4. So 3/7 is going to be 0.428571 repeating. That's the fraction, actually, believe it. 3/7. It's 0.428571 repeating. So in other words, to go to 3 decimal places is going to be 1.43. Okay. And if I know that the y value is 2 times the x value squared minus 3, okay, this is an ugly number. 100 over 49 times 2, which is 200 over 49, which is really, really close to 4, minus 3. So this is going to be really, really close to 1. I think it's like negative, or it's positive 1.1 or something like that. 1.1. Hang on, it should be positive. Yeah. So there's the x value, negative 1.43. And here's the y value, positive 1.3 or 1.1. So let's do that. Negative 1.43, and I think it's positive 1.1. It's really, really close to that. Okay. Let's see the last page here. It says the dimensions of a rectangle. They're represented by x minus 4 and x minus 9. So in other words, this thing's a rectangle, right? X minus 4, x minus 9. This is x minus 4. This is x minus 9. I don't know what they are, right? But I know that 4 is bigger than, oh yeah, if I minus off the 4, that's actually bigger than, it doesn't really matter which order you put them in, but I'm going to put them there. It says the perimeter can be expressed as 2y. Hang on, 2 of these and 2 of these, right? Because the perimeter is 2 of those plus 2 of these. So the perimeter is 2y. So 2y is equal to 2 x minus 4s plus 2 x minus 9s. And it says the area is represented by this. Write the terms in x and y. I know that the area is just going to be length times width. I don't need to double them up. It's not 2 of these. No. Perimeter is the distance. This is just length times width. That times that is equal to 3y minus 9. So you know what? We can actually clean these up a little bit. Look, I could expand these all out. 2y is equal to 2x minus 8 plus 2x minus 18. You know what would have been easier? Just divide everything by 2 right off the bat. What do you mean? 1y is equal to 1 of these plus 1 of these. Oh yeah, because if the total perimeter is all the way around, that's 2y. Well, what's the half perimeter? The half perimeter is from one corner to the opposite corner, and that's 1y. So in other words, x minus 4 plus x minus 9 should equal the half perimeter, which is, if you cut this thing in half, that's halfway around. It's y. So in other words, what do we got? 2x's, 2x minus 13, right? Y is equal to, that's an easy linear equation. This one's going to be a little bit of a parabola. So x squared minus 13x plus 36 plus 9 is equal to 3y. I'm going to put the 9 over there just because I know that these two can go together. So in other words, what do we get? X squared minus 13x plus 45 is equal to 3y. Parabola, line. Solve the systems. Okay, let's just do substitution. Probably the easiest way of doing it. Y is equal to this. That's all going to get plugged into the y value right there. Okay, so here we go. X squared minus 13x plus 45 is equal to 3 times y. And y is this. It's 2x minus 13. Okay, let's solve. x squared minus 13x plus 45 is equal to 6x minus 39. Subtract off 6x from both sides, minus 19x. Add on 39 to both sides, 70, 84 is equal to 0. I don't know if this thing will factor or not. Two numbers are multiplied to 84. 1 times 84. 2 times 42. 3, I don't know if 3 divides in. 4 times 21. 5, 6. 6 times something. 6 times 14, I think. Hang on, 7. 7 times 12. There it is. 7 and 12 add up to 19. Well, hang on. They're both positive? No, they're both negative because they multiply to 84 and they add up to this. There it is. This one actually factors. X minus 7, x minus 12. Now, if you didn't see that, big deal. Go to the quadratic formula. That's why we have a quadratic formula. So x is either equal to 7 or x is equal to 12. Now, because I'm a grade 11 student, I'm suspicious and I don't think there's two answers. What do you mean? I should probably check this. Does 7 work if I plug it in? Look, 7 minus 4, which is 3, and 7 minus 9, which is minus 2. Oh, 7 doesn't work, right? Now, I should probably, I have just figured out the x values, so I should probably figure out the y values too, but I have a feeling this one's not going to work. Let's try it. Remember, what is y equal to? Remember, I could plug it into either one of these equations. Go for the easier one. And besides, I've already isolated y equals. So 2x minus 13. 2x minus 13. So 14 minus 13, y is equal to 1. So 7, oh, that's a terrible 7. 7, comma 1. X and y. And remember, it says the perimeter is 2y. So if this is 7, do you really think the perimeter is 2 times 1? Yeah, that one's not going to work. Hang on, let's try the other one. Y is equal to 2x minus 13. So in other words, it's 24 minus 13, which is 11. So when the x value is 12, the y value is 11. That one might work. Okay, so, but there's the solution system, solution to this system. Determine the dimensions of the rectangle. Okay, so remember the dimensions we said were x minus 4, x minus 9. So if x is 7, x equal to 7, I get 7 minus 4 and 7 minus 9. No, it doesn't work, right? So even though this is a point of solution for this system here, it doesn't work in the original rectangle. So that's why I'm going to have to throw this one away. Let's try it. X equal to 12. So I'm going to get 12 minus 4 by 12 minus 9. So in other words, it is 8 by 3. Is this in centimeters? It doesn't say. But hang on. If this is 8 and 3, 8 by 3, 8 by 3, the half perimeter is 11. Yes, it is. And what's the area? 8 times 3 is 24. And it says the area is 3y's minus 9. What's 3y's minus 9? Hey, it is 24. So this actually works. So it is 8 by 3. This one works. Yes, this one doesn't work. And the perimeter and the area, well, we just did that. So the perimeter, remember we said if this is 8 by 3, 11 is the half perimeter, which means the full perimeter is 22. And the area turned out to be 24. Now, how did I figure those values? Well, I either go back to my original diagram, which is probably the easiest one, or you know what? You just figured out what y was. So y is 2 perimeters, and the area is 3y's minus 9. So the y value is 11, so 2 times 11, there it is. Okay, so that is a pretty long review. The test that I'm going to put on for Friday will be certainly not as many word problems. It'll be a little bit more straightforward. Doing this by a substitution, doing this one by graphing, etc. Alrighty, good luck with these.